federation, equivalent federating the provinces. It's essentially a joint venture. We are what's called the lead agent for it, which means all the money flows through us, but we have to hand it out to other people. So, I mean, that's the mechanism. It says that for all of these areas, grid computing, data and compute, there is sort of one peak organisation, which is a federation of the state facilities. So it makes it very simple because you know who's responsible for what. VPAC itself, we're a cyber infrastructure company. We were founded back in about 2001. We're an independent company. We're owned as a not-for-profit company by all the universities in the state. We do collaborative R&D with the universities and the research agencies. We're what's called a research services company. What we deliver is services. We run compute facilities for the universities. We develop software, both commercially and academic. We avoid competition with the universities because we do no independent research. And by and large, universities don't offer any useful services. Well, aside from teaching and research, the universities don't provide utility services, right? We operate most of the facilities in the state, some of which we own, some of which other people own, and they give them back to us. They realise that running clusters is not a fun game. We also operate facilities on behalf of companies such as General Motors, Boeing, and a few others under various level service agreements. It's not socialist, though. Americans, when I start saying this, get very worried. They say, this is like healthcare. Got to be mandated to use this stuff. No, it isn't. There's no mandate for anybody to use us. Some groups operate their own facilities. And we also don't get state subsidies. We were funded by the state, and we are funded by the state for project-by-project basis, but we don't have any ongoing funding from them. But why it's managed to work for us is what's called the economy of scale. If the larger you are, the easier it is to support multiple facilities at once. The problem that small e-research service providers have is they've only got one grid computing person, and when they go on vacation or get chewed up by a bear or fall off a slope or something like that, you've got nobody there to do the work. Whereas typically we have 2 or 3 or 4 deep people in most areas to do the work. So we get funded by a number of different sources: universities, state and Commonwealth government, industry, and so on. We employ over 70 people at 4 locations in the state: system support, software engineers, scientists, and so on. We have over 500 users across the 8 universities. We run about 5 or 6 HPC clusters. We run GPGU systems. We run Viz systems too. The other thing that we do a lot of, excuse me, we do a lot of software development, but we run it as almost like professional software development teams. We have a process in place for gathering requirements, and we do what's called agile software development, if you're familiar with that. Especially in the domain of e-research cyber infrastructure, people don't know what they want until you give it to them. Actually, after you've given it to them, they probably still don't know what they want, or they change their minds. But at least you've shown them what it is that they don't want, so that next time when they tell you what it is they don't want, you know what it is that they don't want. Something like that. So we do a lot of software development. Some of it's not for profit, some of it's for profit. So obviously we charge General Motors what's left of it, lots of money if we do development for them. So we also do a lot of work with the USA and other groups in geodynamics. We worked a lot with the cyber infrastructure group at the NSF at Caltech. Okay, so Victoria has actually got quite a mature cyber infrastructure structure, right? The universities are organised. They have cyber infrastructure directors. We all collaborate. And what that's actually meant is that we've had a lot of runs on the board, and now the state government and the Commonwealth are injecting a lot more funding. So just in the last 12 months, the state government and one of the large universities have jointly funded a $100 million centre in computational life sciences. There's another $10 million facility for imaging and image processing at the Australian synchrotron. We're in that joint venture too. And there's a biotechnology research centre going in at another location. So this is just the state investment alone. Is stacking up to the 200 million level. The national investment, again, 150, 200 million. But what we found is that once we had runs on the board and successes, we were able to sort of get to the politicians and convince them that they needed to put more money into cyber infrastructure. So I want to talk about BioGrid now, and I'll just do a little demo of a real application that's been great for us. So if I just hit an escape key here. Hold on for 1 second. So I could talk about cyber infrastructure in general, but I thought it was good just to spend 5 or 10 minutes on one really exciting production project that we have. It's called BioGrid. The project manager for this is a VPAC employee. They're on YouTube. There you go. They must be good if they're on YouTube. And they're at biogrid.org.au. Let's see. So it's funded. Its vision without funding is hallucination. So they managed to get quite a lot of funding for this. From the state and federal government. So again, we're talking 11, 15 sort of million. At the moment, too, what they're doing is they've established this rather large network for collecting clinical data. And what this has actually done now is getting investments from the pharma companies. The pharma companies are saying, you guys have got such a large network for getting access to clinical data, we're actually willing to pay money to get access to that network to do data mining and studies of effects across large groups. So here's the idea. What you typically have is you've got federal population data from the Australian Bureau of Statistics, you've got state health data, you've got clinical data which is gathered in hospitals. Typically it's by research groups. So the clinical data is gathered by, say, a research group who treats people in, say, cystic fibrosis or colorectal cancer. I'm sure the same situation exists here. Different hospitals and different groups will specialise in treating certain diseases. They accumulate fairly large chunks of data over long periods of time. Typically in the past, they've only used it for their internal purposes. If you just take colorectal cancer in Australia alone, though, there are around about, across the country, around about 9 to 10 major centres which treat that, which gather that data. So the motivation was being able to federate all of that research data to be able to do much, much larger studies with much greater statistical significance. So the idea is people collect clinical data with scientific tools. These could be samples, histological samples, and so on. Then we put it into a virtual data store. The principle that we actually use is that the hospitals still own their own data. If you go to researchers sometimes and say, oh, give me your data, right? Typically their first question is, well, you can't have my data, but you can have my sister or my dog or something else before you can have my data. So what we generally do first is we essentially mirror their data, or we copy the piece of the data that we actually need. We federate it. Eventually, when they get to trust you more, eventually they kind of say, well, yes, you can have my data. So never go to somebody and say, I want your data. Then that goes into research tools which can analyze that data, and collaborative research across multidisciplinary teams. And then that goes eventually into publications and new treatment. So we're actually at the stage, we've now gone to the end of this. There are published results of it. We're now building web tools, for example, that are being deployed based off some of this data to actually do, for example, chemotherapy prescribing. Chemotherapy up to now is people scribble something on a piece of paper and hopefully you got it right. Whereas we build essentially web tools which will automate and enable that process to go, working with the clinicians to see what it is they need to do. There's a lot of challenges. Ethics is pretty significant, obviously in clinical data. What we've done is we've worked with the hospitals themselves to advance that. Heterogeneous systems is a problem. Every hospital tends to have its own data system, its own standards. And different groups as well will have different classification schemes. Also for disease, the classification schemes change over time, right? You can never freeze a medical system. Otherwise, you walk along and say, look, I've got a case of SARS. And they say, well, it's not in our computer. We can't treat you. Maybe you should go away and have something different instead. So anyway, this is all problems. You've got to have people who are champions of this. That's the key. And usually it's the clinicians who are the drivers of this. So we have to have a sustainable data collection, and we feed it into quality control systems. It's all cross-institutional. What we do is we have template agreements. I'll explain it in a minute.